Hello students, welcome back. Now in this part I am going to tell you about the basic definition of derivability or differentiability. So how it is derived and how it is applied in the problems that we are going to learn in this part. So let's start. Okay, so now let me tell you about what is differentiability or derivability of a function. Okay, so first of all let me tell you what is the meaning of differentiability of derivability, right? Both the terms are same, right? It exactly has the same meaning. So first we will look at the physical meaning of derivability, right? What is the physical meaning of differentiation? Physical meaning is nothing but instantaneous rate of change. Now instantaneous rate of change means, what is differentiation? Basically what is differentiation? Differentiation is dy by dx, right? So dy by dx means this is nothing but instantaneous rate of change of y with respect to x. So at what rate y is changing, right? So change in y with respect to change in x. This is dy by dx, right? So physical meaning is instantaneous rate of change, right? At that particular instant, what is the rate of change of y with respect to x? That is given by dy by dx. Now, what is the geometrical meaning, right? If we see geometrically, the meaning of differentiation or the meaning of dy by dx basically is the slope of the tangent to the curve at a particular point. Okay, so suppose if this is y-axis and this is the x-axis, I have a curve like this. Suppose this is a curve fx, okay, and I want to know what is dy by dx at some x naught. Suppose this point is x equal to x naught. Now if I want to know what is the dy by dx at this point, let me say this point is point A, right, then dy by dx is nothing but it is the slope of tangent at this point, at this particular point. So slope of this tangent, right? So the slope of the tangent is nothing but dy by dx at which point? At x equal to x naught. Okay, so the geometrical meaning of dy by dx is nothing but slope of a tangent to the curve at a particular point, right? Here this is the slope of tangent to this curve fx at a particular point x equal to x naught. Okay, so geometrical meaning is slope of tangent to the curve at a particular point, and physical meaning is instantaneous rate of change, right? This is clear. Now let us talk about the mathematical definition of derivability and how to know whether a function is derivable or not, right? Suppose if some random function is given to you and it is asked whether this function is derivable or not, right? How to find out whether a given function is derivable or not? Now to know this, what we will do is we will find out first of all what is called right hand derivative and left hand derivative, right? In continuity we have seen that we had LHL and RHL, right? Left hand limit and right hand limit, and we say that a function is continuous if LHL is equal to RHL is equal to, what is the condition for function to be continuous? LHL is equal to RHL is equal to finite, right? Both the left hand limit and the right hand limit should be equal. Now in case of derivability we have right hand derivative and left hand derivative. Okay, now what is the definition of right hand derivative? That I will tell you in a while, right? So consider that this is a graph of some function. This black colored is the graph of some function fx. This is my y-axis and this is my x-axis. Now there are 2 points A and B which I am taking on this curve, A and B. Okay, now this point A corresponds to x equal to A, and for x equal to A the value will be f of A, and at x equal to B the value of the function is suppose f of B, right? Now what is dy by dx? Dy by dx is nothing but slope of the tangent, and here in this case AB is a secant, right? So what will I do if I want to convert this secant to a tangent, right? So the method for this is, if I bring this point B closer and closer and closer and closer to very close to A, right? So I move this point B on this path, and when it reaches here, very close to, right, this gap is very minimum. Okay, so if I bring this point B very close to point A, so suppose this is the x coordinate of point B, it will be A plus h, where h is a very small positive quantity. What is h? H is a very small positive quantity, right? So x coordinate is A plus h. So what will be the value at x equal to A plus h? At x equal to A plus h, the value of the function will be f of A plus h. Right, now what is dy by dx? Dy by dx is nothing but change in y with respect to change in x. Okay, so what is the change in y? Change in y is f of A plus h minus fa. And what is change in x? Change in x is nothing but A plus h minus A. A plus h minus A is h. Okay, so this is the right hand derivative. Right hand, why this is called right hand derivative? Because we are approaching from the right hand side. Okay, we are bringing this point B very close to A, right? So we are approaching this point A from the right hand side, right? I am approaching this point A from the right hand side. And similarly, if I bring this A very close to B, right? So suppose here if I bring this point A very close to B, so this point will be nothing but B minus H, and the value at x equal to B minus H will be nothing but f of B minus H. In this case, I will get the value of left hand derivative. So left hand derivative will be, I can just replace B by A, right? Because whether I take x equal to A or x equal to B, both of them are just values, right? Variables. So I can change the variables. So this will be A minus H minus Fa, right? This is Fa minus f of A minus H if I reverse the sign. And in the denominator I will get B minus H. So B minus H will come in the denominator. Change in y with respect to change in x. So this is the change in y and this is the change in x. So if I approach from left hand side, I will get this. This will be the value for left hand derivative. And if I approach from the right hand side, this point A, then I will get this, which is called right hand derivative, right? And when can I say that dy by dx will exist? Derivative will exist, right? The derivative will exist if left hand derivative is equal to right hand derivative is equal to finite. Now this condition is exactly same as the condition for continuity. There we have LHL RHL, here we have LHD RHD. This LHD RHD are nothing but left hand derivative and right hand derivative. If left hand derivative is equal to right hand derivative is equal to finite, then I can say that derivation of that function derivative exists. Now derivative exists means dy by dx is possible, right? We can differentiate that curve. The curve is differentiable. All these are the terms that we can use. I can say that derivative exists, or dy by dx exists, or I can say that the function is differentiable, right? It is derivable, differentiable, all this I can say if LHD is equal to RHD is equal to finite. Remember, it should be finite. Okay, so this is the condition for a function to be derivable. Now let us go to the next slide. Now let us solve some questions, right? Then only it will be clear, your concepts will be clear. So suppose I take the first example here, that is fx equal to x square at x equal to 1. Now all of you, those who have a little bit knowledge about derivatives, right, those who know how to differentiate this function fx directly, right, you might have already learned, some of you. So we can directly differentiate this function. So what should be our answer? F dash x will be nothing but 2x, and if I talk of the value of dy by dx at x equal to 1, then what will be f dash 1? At x equal to 1, I will get the value of this should be 2. Now let us prove this by using the definition that we have just learned, that is by finding out left hand derivative and the right hand derivative, right? Because the question says that you have to find left hand derivative and right hand derivative. Now what is the definition for right hand derivative? Right hand derivative is nothing but, if I talk about the right hand derivative at x equal to 1, then this will be nothing but limit h tending to 0 f of 1 plus h, because I am talking about at this point x equal to 1. So this is f of 1 plus h minus f of 1 divided by h. This will be right hand derivative, and what will be the definition? According to the definition of left hand derivative, this will be limit h tending to 0. Now here I will get f of 1 minus h minus f of 1 divided by minus h. Now let me find out what will be RHD, right? What will be f of 1 plus h? F of 1 plus h will be nothing but 1 plus h whole square minus f of 1 is 1 divided by h, and here I have limit h tending to 0. Now this will be nothing but, if I simplify this, I will get 1 plus 2h plus h square. So h square plus 2h divided by h, and here I have limit h tending to 0. So this will be nothing but limit h tending to 0. I will get h plus 2. Now if h is tending to 0, this value will become 0. H is tending to 0, right? So the limit of this function will be 2. So RHD is right hand derivative is equal to 2. Now let me find out what is left hand derivative. What is f of 1 minus h? See, f of x is x square. So I will replace x by 1 minus h. So f of 1 minus h will be 1 minus h whole square minus f of 1 is 1, right? Because 1 square divided by minus h. And what is the limit? Limit is again the same, h tending to 0. Now this will be how much? This will be 1 minus 2h, right? So basically I will get minus 2h plus h square divided by minus h. And here again the limit is tending towards limit h tending to 0. So basically I will get here 2 minus h, right? This will be 2 minus h, and limit is again h tending to 0. So if h is tending to 0, this term will become 0, and again LHD also I will get equal to 2. So in this case I have LHD equal to RHD, left hand derivative is equal to right hand derivative is equal to 2, which is a finite quantity. 2 is a finite quantity, right? So I can say that dy by dx of this function exists and which is equal to 2, right? I can say that dy by dx exists and it is equal to 2. So at x equal to 1, what will be the value of dy by dx? If the function is fx equal to x square, then dy by dx for this function, this is nothing but differentiation or derivative, right? So dy by dx at x equal to 1, this is how we represent dy by dx at x equal to 1, this will be equal to 2. I can say that derivative exists or dy by dx is possible. Okay, it is possible to differentiate this function is derivative. Now let us see one more example. Okay, now let us check this example and find out what is LHD and RHD in this case. Okay, so first of all, if I apply the definition of right hand derivative, again definition of right hand derivative will always remain same. So limit h tending to 0, here what is the point? The point that we are considering is at x equal to 1, I want to find out dy by dx at x equal to 1. So here again the definition will be derivative f of a plus h, so a is 1, right? So 1 plus h minus f of 1 divided by h, and what will be the definition of left hand derivative? Left hand derivative will be limit h tending to 0, f of 1 minus h minus of f of 1 divided by minus h. Alright, now what will be the value of f of 1 plus h? I will just simply replace x by 1 plus h, right? So this will be, let me write down the limit h tending to 0, f of 1 plus h will be how much? Ln of 1 plus h and the mod of this quantity minus f of 1. Now ln 1 will be 0, f of 1 is 0, right? Because if fx is mod of ln x, f of 1 will be nothing but mod of ln 1, and ln 1 is 0. Okay, so this f of 1 will be 0, this quantity is 0, and here also this quantity is also 0, divided by h. Now see, if I look at the graph of ln x, right, what is the graph of ln x? Graph of ln x is something like this, right? This is the graph of ln x. If this is the graph of ln x, this point is x equal to 1. Now I am talking about ln of 1 plus h. 1 plus h means x is greater than 1. If x is greater than 1, right, this point will be somewhere here, 1 plus h. If x is greater than 1, then ln x will be positive. If ln x is a positive one, so this ln of 1 plus h will be a positive quantity. So I can open this mod will open in positive, right, because ln 1 plus h is already a positive quantity. So this will be nothing but limit h tending to 0, and here I will get ln of 1 plus h. So mod will open with a plus sign. Okay, so plus ln of 1 plus h divided by h. Okay, and this limit, if you have studied what is limit, right, and if you know this is the standard limit, so this limit will be equal to 1. This is a standard limit, right? You can go back and recall if you are not aware about this limit. And what will be left hand derivative? Left hand derivative is nothing but f of 1 minus h. So what will be f of 1 minus h? Limit h tending to 0, f of 1 minus h will be mod of ln 1 minus h minus 0 divided by minus h. Now what will be the value of ln of 1 minus h? See, if x is less than 1, ln of 1 minus h, right? So x is less than 1. If x is less than 1, this point is a 1 minus h, then log will be negative. So this mod will open with a negative sign. So if I open this mod with a negative sign, because ln of 1 minus h is negative, this quantity is negative. If this quantity is negative, I will have to multiply by a minus sign so that it becomes positive, right? So minus of ln 1 minus h divided by minus h. So this minus minus will get cancelled, and this is again a standard limit, so this limit will be equal to minus 1, right? So here in this case we have seen that what is right hand derivative? Right hand derivative is equal to plus 1 and left hand derivative is equal to minus 1. So we can clearly see from this two that left hand derivative is not equal to the right hand derivative. So we can say that dy by dx at x equal to 1 does not exist. This function is not derivable at x equal to 1 because LHD and RHD are different, right? They are not equal. So we can say that derivative does not exist. It is not derivable. Okay. Let's move to the next question. Now try to do this question first on your own and then see the solution for this. Right. Again we have to find out LHD and RHD. So again I will apply the definition of LHD and RHD. Right. And this you have to find out at x equal to 0. This part is missing in the question. So question is you have to find out the right hand derivative and the left hand derivative of this function at x equal to 0. This is the question. Right. Okay. So if I find out first of all what is RHD, RHD will be at x equal to 0. Right. So this will be here a is 0, h tending to 0, f of a plus h, which will be f of 0 plus h minus f of 0 divided by h. And what will be LHD? First of all, always write down the definition, then only proceed, right? So there will be no chances of making any mistake. So again I will write down the definition, 0 minus h minus f of 0 divided by minus h. Now what is f of 0? f of 0 will be e to the power mod of 0, and this is nothing but e to the power 0, which is equal to 1. So f of 0 is 1. And what is f of h? F of h will be, let me write down limit h tending to 0, then this is nothing but f of h. Now f of h is e to the power minus mod of h and minus 1 divided by h. Okay, now see, this h is a positive quantity, right? What is h? H is a positive quantity, so I can just remove the mod, right, because h is already a positive quantity. So this will be limit h tending to 0, and here I will get e to the power minus h minus 1 divided by h, and this limit will be equal to nothing but minus 1. This is again a standard limit which we have studied in the chapters of limit, right? Here again, what will be f of minus h? F of minus h, I will replace x by minus h, right? So this will be e to the power minus of minus h mod, and minus f of 0 is 1 divided by minus h. Now what will be mod of minus h? Mod of minus h, right? H is positive, minus h is negative, so this will be nothing but h, right, which is a positive quantity. So this will make this mod positive. So this will be limit h tending to 0. So I will get e to the power minus h minus 1 divided by minus h, and the limit for this will be, if this limit is 1, then we have one minus sign which is extra, so this limit will be plus 1. So in this case again we have seen that right hand derivative is equal to minus 1 and left hand derivative is equal to plus 1. So again we have seen that right hand derivative is not equal to left hand derivative. So again this function is also not derivable at x equal to 0. So dy by dx of this function at x equal to 0 does not exist. Does not exist, right? So this function is also not derivable at x equal to 0. Okay, so I hope this is clear to you, all of you. If you have any doubts, then you can log into www.askIITians.com, and then you can click on the discussion board, which will redirect you to this page where you can see Ask Expert on the right hand side. From here you can select the category of the question and you can post your question here for free, and the experts at Ask IITians will answer your question within 24 to 48 hours. So students, I hope this is clear to all of you that when a function is differentiable and when a function is not differentiable. Right, now in our next part I am going to tell you about the different theorems that are related to differentiability. So do not forget to watch the next part.